For this problem, we're going to solve a logarithmic equation. Here we have log of x plus 9 is equal to 2. There's no base written here, so we need to remember that that's really log base 10. The implied 10 is not written. The variable we're solving for is inside the logarithm. We need to get that out. The way we're going to do that is remember that if we have the logarithmic form, y equals log base a of x, that's equivalent to saying a to the y is equal to x. So the logarithmic form is equal to this exponential form. We want to rewrite this logarithmic equation in an exponential form. So we're going to take the base, which is 10, raise that to the power 2, and that has to equal the inside of the logarithm, x plus 9. 10 squared is 100, so 100 equals x plus 9. Subtract 9 from both sides, we get that x is equal to 91. Now that we've solved this equation algebraically, let's move to our smartboard interactive whiteboard and solve it using a graphing utility. To solve this equation using our graphing utility, we first notice that we have expressions on both sides of the equation. So we're going to enter our left side as y1 and our right side as y2 and look for the intersection point of the two graphs. We go to our graphing calculator. In y1, we're going to enter log base 10 of x plus 9, close parentheses, enter, and in y2 we enter the constant 2 as the right side of our equation. We're going to graph that using our standard viewing window, which is minus 10 to 10 in both x and y. When we're looking for the intersection point, we can see the graph of y1, the logarithm, is rising slowly, but it is approaching our constant 2. So we feel pretty confident it's going to intersect, but it's going to intersect very far out there in x. So we want to pick a very big number for, or at least somewhat larger number for our x max. You also notice a lot of white space in the y direction. We don't need all that. In fact, we're looking for an intersection point that has a y coordinate of 2. So we don't need our max and min in the y direction to be much beyond 2. So we'll go to our window setting. X min we can leave at negative 10, because we know our intersection point is further out in the positive direction. Our x max, we want to pick a bigger number. So let's pick something like 150. And we'll want to change our scale here since we're using such a big number. Let's go ahead and scale by 10. Now for our y min, remember our y coordinate is going to be 2. So let's choose a y min of 0 and y max of 4. So we surround 2, but we don't go much in either direction. We'll go ahead and keep our y scale as 1 and graph that. So here we have the graph of y1, and we get the graph of y2 coming across. You can clearly see that they cross here, and we know the log is going to keep increasing, so they won't cross again. So there's only one intersection point. We need that x coordinate there. So we're going to find the intersection point using our calc menu. Pick option 5 for intersect. First curve, we're on y1, so we just hit enter. Second curve, we're on y2, hit enter again. And for our guess, we'll scroll a little bit to the right, get a little bit closer to the point where the graphs cross. And we'll hit enter. And we see our intersection point is at the point 91, 2. So we're solving the equation log base 10 of x plus 9 equals 2. Using our graph, we see that the intersection point occurs when x is equal to 91. So the solution set to this equation is just 91.